Hello, it's great to be here. I'm going to talk about serverless containers and how well they work. But before we do that, there is something else very important that we need to talk about. And this is what I look like when I'm wearing a denim jacket. My name is Martin Omander, and I was born and raised in Sweden, just on the other side of the bridge. I'm sort of home in Sweden on vacation now and swung by. Kevin invited me. I've lived in Silicon Valley these last 19 years, and that's where I'm based out of. And I worked at 3 startups as a software engineer. Right now, I worked at Google for the past 13 years, and my current job at Google is that of a cloud developer advocate. So when you're a cloud developer advocate, that means you have 2 jobs. One job is to tell awesome developers like you guys about Google products and how you can use them, and to stand on Google's shoulders and achieve more. The other job is to listen to you developers. Some of you are using the Google Cloud Platform, and I'm sure you have opinions about what could be improved in it. Some of you are not using Google Cloud Platform. I would love to hear those opinions as well. What is stopping you? Because I'm meeting with the product managers and the engineers, the folks who are building these products that we'll be talking about in a minute. I meet with them every week, and they keep asking me, Martin, what is it people are doing? What feedback do people have out in the field on these products? Because they are in the office all day building the product, so they don't have time to meet all you awesome developers. So I would love to hear your opinions about the Google Cloud Platform after the talk. There will also be a survey that will be up here after my talk, and I would love to hear your thoughts. All right, so in this talk, we are going to talk about Lily. She started she's a veterinarian. She started a pet clinic. She calls it Pet Theory. She has some values that are very important to her. They are environmentally friendly. They listen to both the pets and the pet owners. In veterinarian circles, this is called clients and patients. If you never heard of them, it is because I totally made this company up. But we're going to follow this company as they move from an on-premises solution into the cloud and using serverless containers. So Lily started this business some years ago, and it has gone very well. These values really speak to people, and she started up clinic after clinic after clinic, and now she's at the point where she has thousands of customers and hundreds of employees, 34 clinics. So now all of a sudden, business is great. People love Pet Theory. But it means that some of the IT systems they set up when they had 1 or 2 or 3 clinics, they don't work anymore when you have 34 of them. So some things here, for example, is you have clients, these are the pet owners, they have to call to make or change appointments, and sometimes people don't pick up. The receptionist doesn't have time to pick up. They find that very annoying. Veterinarians, they see that they're doing a lot of paperwork and dealing with insurance companies rather than spending time with the pets. Lisa, she's the poor receptionist here. She has to answer all these calls. She also has to send out the invoices, and that is manual work, and sometimes she doesn't have time to do that and answer the phone at the same time. And then, of course, we have Patrick. Patrick has been with the company for a long time, and he just knows he's a little bit in over his head here. It was easy for him to take care of the on-prem system they had for dealing with pet data when they had 1 clinic. But now when they have 34, it's just way too much, and the servers keep crashing. So Lily realizes that these IT growing pains, I need somebody to come in and help me fix them once and for all. So she hires Ruby as a consultant, and she tells Ruby, can you fix this for me? Ruby says, yep, let's the 3 of us, you, me, and Patrick, sit down and write a list of how we can improve the current IT infrastructure of Pet Theory. So here's the list. They agree on, first of all, they need to make the pet records available online, both for staff and for the clients. Then they will need to make pet appointments available online. So the clients can, these are the pet owners, they can see appointments, change appointments online, and the staff can do the same. Then they need to automate the sending of invoices. Remember Lisa, the receptionist, she had a hard time answering the phone and sending the invoices. And finally, they need to open up to other players in the ecosystem, like insurance companies or calendaring apps, so that make this data available through an API to other players. So Ruby says, if we do these four, we'll be in a much better place. And we'll be taking the first few steps on the digital transformation of pet theory. However, if you've ever been in a situation like this, where you're moving stuff to the cloud, you know that there are two ways you can build modern cloud systems today. One way is to build it with Docker and Kubernetes, like go the container route, right? The other way is to go the function as a service, platform as a service. So this is like Google Cloud Functions. Or Azure, what is it called? Azure Functions? Is that what they're called? Yeah. Amazon Lambda. Has anybody used those serverless things on the right, like Cloud Functions, Azure Functions? Yeah. Okay, cool. How did it work for you guys? It worked well? Yeah. Was it limiting, or you didn't feel that? It's fantastic. Oh, excellent. Great. It has, for sure has some great advantages to it. So, first of all, the Docker and Kubernetes stuff. Has anybody here used Docker or Kubernetes? Okay, about half, as many. Yeah, cool. So you know that when you run containers and Kubernetes, you have fine-grained control, and you can use any binary, any languages. You can use whatever you want. You just put it in the container, right? It does come with some disadvantages, though. So there's setup and maintenance work. You have to provision resources, and you will often pay for resources that you don't use. Resources and servers you have sitting around just in case there is a spike in demand. So on the serverless side, there is none of that setup, way less of that setup. There is, you only pay for your use, so it's really liberating. But at the same time, it's not as flexible as Docker and Kubernetes. You can't run any language. It's a little hard to move functions around. If you build something on Azure Functions, it's kind of hard to move it to Google Cloud Function and vice versa, and Amazon stuff too. So this is a bit concerning. Patrick, he wonders like, hey, Ruby, what if we choose the wrong path here? What if we discover that we choose serverless and that path that leads to nowhere? Or we choose Kubernetes and we don't have the skills for that in-house. We discover it after a while. What if we choose the wrong path? Well, Ruby has good news, because Ruby has read up about this new trend in cloud computing. And that is that serverless and containers are starting finally to come together. They split apart some 10 years ago, but now they're starting to come together again. So now we can pick that thing in the middle, and there's far less chance of us picking the wrong thing. And by doing that, you get the advantages of containers and serverless, and you don't have to deal with as many of the disadvantages of either platform. So the product here is called Cloud Run, and that is, we'll see some code that Ruby is writing to accomplish these 4 things we saw in the list. She will implement those in Cloud Run. We'll see how that works. Also, just to, where does Cloud Run come from, and what is really Cloud Run? Well, we can think about it like this. In the beginning of time, there was Linux. So Linux, you can run it on your own machines. Many of you do that. You can run it hosted on Google Cloud Platform, or you can ask Amazon or Pivotal or any of the other ones to run Linux for you, hosted. If you run it on your own machine, you have to do a lot of setup, but it's perfectly possible. If you run it in the Google Cloud or in somebody else's cloud, there is a lot of setup is done for you. So Linux is there. And this was cloud computing. Like 10 years ago, cloud computing was this. Then, however, there's some disadvantages to this model. It's kind of hard to scale up because you have to keep installing new machines. And if one machine breaks, it doesn't automatically route around that machine. So some years ago, Google released Kubernetes. It's a container manager. It's open source. You can download Kubernetes right now, install it on your machines, and run it yourself. Or, if you prefer, you can have Google run it for you, and then a lot of the config stuff is already done. It's a lot easier. That's called Kubernetes Engine, is what the product is called. So until 2 months ago, this was the state of cloud computing. 2 months ago, though, we got Cloud Run. And this is Knative. Knative is built on, it's a serverless platform. It's open source. You can go and download it and start running it tonight. It's built on top of Kubernetes, and it simplifies the developer experience. So instead of having to deal with different machines, you have a serverless experience. You write your code once, you don't need to know about different servers. You can run Knative yourself, or you can ask Google to run it for you. And in that case, the product is called Cloud Run. Has anybody here used the Kubernetes Engine product? A few. Oh, quite a few. Okay. So for those of you who just raised your hand, I want you to know as well that you can, there's kind of two flavors of Cloud Run. We are going to look at the completely serverless one, where we'll see what they do. You don't configure machines or anything. If you already have a Kubernetes cluster and you want to keep using that, you can actually run Cloud Run inside your existing Kubernetes cluster as well. I won't talk much about that. I'll talk about the completely serverless Cloud Run, but you should know that there are two flavors. All right, great. So a lot of talk. Let's see a demo. This is making pet records available. Okay, so this is about uploading data. This is a data migration script we'll see here. Let's run it. Ruby, she managed to get a CSV file out of the old system. It looks kind of like this. Well, this is the file. It has like customer ID, customer name, customer phone, everything like that. And we see here the various records. And let's see, 20,000 records. Okay, so this is a pretty small file. But I'm now going to upload it to the system, and it will be imported into the database. Now, let's see here. Pet theory, import pets, test data. We'll open it. It's about a megabyte in size. So it is, we'll make it a little bigger here. So right now, this CSV file has been uploaded into Google Cloud. It is churning. It is, Google Cloud is going through the file and storing everything in the cloud database. And then when it's done, it will delete the file. That's how we know it's done. We'll give it a few more seconds here. Okay, so the file is gone here, and now we can go in and look in the Firestore database. This is a NoSQL database, super scalable. Here we now have, so for example, we see here, pet with ID 10033. Here's the customer name, phone number, and so on. Here's another pet. So all these were imported just now. Let's see what that actually looked like, what Ruby had to build for this. So legacy system, this is the old system that keeps going down. CSV file, that's the file she managed to get out of that system. You saw me upload it into Google Cloud Storage. And then from Cloud Storage, there was a notification sent with Cloud PubSub. Cloud PubSub is a sort of glue that holds all the products together in the Google Cloud Platform. You can send notifications between different products, and the different scripts and things and programs you have can subscribe to these. So Ruby has written an ETL app here in Cloud Run, And that takes the storage from storage and then puts it in the Firestore database. And ETL stands for, I keep forgetting. It reminded me, does anybody remember? Extract, yeah. Transform, load. Thank you, yes. So extract from the file storage, transform, there's not a lot of transform here, and then load, that is putting it in the Cloud Firestore database. All right, let's look at that. So this is a Cloud Run service that Ruby has written. So any Cloud Run service, you're right, has to listen. The way it communicates with the runtime around it, with Google Cloud Platform, is that it has to listen to HTTP calls. That means two things for a Cloud Run service. One, you need to include an HTTP library in there. And second, it needs to be stateless. So no remembering stuff, not between runs. You shouldn't depend on variables being the same value as before. If you do these, if you follow those two rules, you get some, well, actually, if it's stateless, it's kind of pointless. If you have data, you need to store data somewhere. But the thing is, you don't store the data in the Cloud Run service. You store it in one of the many databases that exists in Google Cloud Platform. And you can, of course, use like machine learning APIs and other databases, file storage. All those things are highly stateful, right? But they're outside the ETL app, outside the Cloud Run service. So if you write something that can listen to HTTP and that is stateless, you get then Google can do some cool stuff with your code. Because as usage ramps up, Google can just create more of those services. They're stateless, right? So they can just be, logging and error reporting. You get that for free, of course, and debugging. Okay, so Google can scale up and just create more of your service because it's stateless. Also, Google can scale down. So what we're looking at here is actually, this is June, the first 2 weeks of June. Whenever there's a bar, that means that that day the service was used. And when there's no bar, that means the service wasn't used. And Ruby paid $0.00. So it scales all the way down to 0 as well. That's what's cool about serverless. All right, so now she writes this in JavaScript. Who here has done node programming, JavaScript? Wow, lots of, okay. And you were sort of, a little bit, yeah. Who here, under protest, perfect. I was going to ask, who here likes server-side JavaScript? I do. You're not raising your hand, I noticed, yeah. There were way fewer hands that went up, yeah. So server-side JavaScript, yeah, it's a little weird, but you can totally do it. Not everybody likes it. The good thing with Cloud Run is that you can write whatever programming language you want, as long as you find a runtime for it. But Ruby realizes her ETL script, it's index.js, that's like 50 lines of code, but her code, and most of the code you write, is so much more than just that code, right? They're all the libraries. And this has always been a problem before. You would deploy just the yellow box, and then because the libraries are different on the server, things would break. However, now, all of those of you who have worked with containers, you know that this has been solved now, right? Now, we don't deploy just the yellow box. We deploy this whole container that contains all the libraries of the right versions. So it's way safer to deal with containers than to deal just with the developer's source code. How do we define what's in a container? Any thoughts? Anybody worked? Docker, yes, excellent. Yep, Docker is the industry standard. So here's a Docker file that says, okay, we should base the container on node 10. So this is node version 10. There's a base image. Then run npm install. That is like it installed all the dependencies. And the dependencies, they live in another file, package.json. If you use Python, this file is called requirements.txt instead. Various other languages have their own dependency formats. But this is how you package everything up and show which libraries you're using and what versions. So once you pack that up, you can then look at her code here. Here is a post. So she's listening for a post. She's using the pub sub notification that comes to her code is an HTTP post. And she checks that the event type is object finalized. That means the file was written. And then unpack the file and then import file. And in the function import file, that's where she's parsing the CSV file. She's writing to Firestore. Return status 204. What? It's not 200 like we're used to. What is 204? Does anybody remember? Object created. Kind of, yeah. Not exactly. I think it's called something else in the spec. Does anybody remember? I had to look this up. It means okay, like 200, but 200 means okay, and here's some content back for you. 204 means it's okay, and I have no content for you. Yeah, we don't use that very often, but it's useful in this context. Anyway, this is the service, and then she needs to implement the import file. All right, so now the data is in Cloud Firestore. Now let's look at the clients here. iOS, Android, web. These are clients that they're going to read from the database. And let's see what that looks like. Demo time. So we have this here. We have this here. Let's see. Okay. So over here on our left, we have Carolyn McKissick. Oh, hard name to say. She's logged into the Pet Theory customer portal. She's a customer. Her pet's name is Mary, okay? Over here on the right, we have the clinic administrator. So this is Lisa. She's working at the clinic. She has pulled up Carolyn McKissick's record here as well. So Carolyn, she says, okay, there's no appointment for her pet Mary. So let's see, Wednesday, Monday. Yeah, Monday 9 is early. Let's say 10. And she requests that. So great, now it's saved in the database. And you notice, because it's using Firebase, all clients are updated updated. So even though there was no reload over here, Lisa is seeing, she's the administrator, she is seeing that Monday, July 1st at 10 o'clock has been requested. And she can say confirm. It's tiny text. It does say confirm there. She clicks the confirm button and it changes to confirmed, and it changes in real time for Carolyn in her user interface as well. So Firestore, the database here, is a serverless database. There was no provisioning of servers or anything. It just scales infinitely. And it is real time. So all clients, that means mobile apps or web clients like here, are updated in real time as data changes. Makes it much more lively and user-friendly. The code for, let's see, what are we looking at here? Oh, right, the way you accomplish this is you write code something like this. Here I want to hit the collection, the pets collection, and in that I want the document that has the customer ID as its name, and then doc.on snapshot. That in that one, I will just unpack the snapshot, and then I will modify the UI. Like this is a JavaScript way of modifying a web, one of the ways you can modify a web user interface, a web page. So what's cool with this is that doc on snapshot, that runs whenever the data is changed in Firebase. So actually, this is client-side code. You notice that Ruby did not have to write any server-side code that listened to requests from the client to get data. So all of a sudden, there's way less code to write if you have a real-time database like this. However, Patrick has some thoughts on this. He looks at the user interface for Firestore, and he says, like, what? But where do I set up capacity? Like I do in a normal database? Or where do I patch the database? Or how do I set up disaster recovery for this? Or how do I set up high availability? Or how do I build the indexes? Well, it turns out that all these tasks, disaster recovery, indexes, high availability, OS config, that's stuff that everybody needs to do. And it's stuff that is very boring and kind of hard to do as well. So the term for that is undifferentiated heavy lifting. And undifferentiated heavy lifting, that's the kind of stuff you don't want to do because you're not better than everybody else at this. Well, if you are, you should do it. Chances are you're not. Chances are your core business is something else. Like Pet Theory, they take care of pets. That's their core business. They should do that. They should not deal with indexes. Let Google deal with indexes. That is the serverless philosophy, and the Firestore database is serverless database like this. You can run backups and such if you want from it. You can run regular scripts and things, but all of this, it doesn't get corrupted and those things like a normal database, server full database does. All right, cool. 2 down, 2 to go. We're halfway there. Automate sending of invoices. Okay, so here, Patrick tells Ruby that the on-prem system that they used to have, it generates docx files. So this is like Word files. And then poor Lisa, she had to manually transform them, convert them into PDF files because not everybody has Word on their machines. So that takes a lot of time. It's not fun. But Patrick, he found a script online, probably on Stack Overflow, that that transforms doc files to PDF files. Excellent. Let's run it, see what happens. Well, first of all, let's look at the code. So here, this gives Ruby some pause. First of all, it's a Python script. Ruby's not real familiar with Python. So it can run, but she doesn't. And second, we see here that this is actually it starts up a sub-process and it invokes LibreOffice and asks LibreOffice to convert this file. So how do I make this work in the Google Cloud? Well, Patrick, he's used to stringing scripts together and installing stuff on local machines, and yeah, sure, we can just do it, of course. Then Ruby realizes that, well, in a container, you can put whatever you want. Let's put LibreOffice in the container. I mean, it's maybe not super fast, and it's not super small either, but at least we get something that works. Just like you can put the cloud storage libraries in here. So she does that, and so here, this line here is basically installing LibreOffice and have it as part of the container. And here's pip install. That's Python's way of installing other libraries, or one of the ways you can install other libraries with Python. Let's run it, see what happens. All right. So this generates the PDF file. Oh, look at that. Ruby is not happy with Patrick. You said this script would work. All right, time to roll up our sleeves and have a good look in the console here. So this is the logging. So all of the, in Pet Theory, all the logs from all their products end up in here. So we see here that we have exception on /get for /. Okay, that's what happened here. We see trace back. Okay, this looks interesting. Let's see if we can make it bigger. Trace back, this was the one I opened, and oh my gosh, here's a big stack trace. But there's something about, this is too much to read. Oh my gosh, let's go to the end. Cannot determine path without bucket name. Okay, so something with paths and bucket names. Buckets, they're kind of like directories in cloud storage. So let's go and debug this in production. This is the code, app.py. All right, so there was something with bucket names, right? Here's a lot of code. We just copied from the internet, so we don't really know what's going on. But here's like bucket, out temp file, out blob. Well, what is all this? Let's just make sure we're looking at the right version. Yeah. Let's just put a breakpoint in here. And let's hit this again. Okay, we still got the server error, right? The code ran, but something is not healthy. And let's see, we run this again. Oh dear. I must have pressed some buttons wrong somewhere, because what it was supposed to show was this. This is the cloud debugger. And any product you run in the Google Cloud, you can put breakpoints in it. That's the arrow over here. And then when it hits the breakpoint, you can see all the variables and the call stack, just like if you were debugging on your local machine. Also, I call this a breakpoint, but it's actually not a breakpoint. It's a snapshot. So it says, like, on line 41, this was the state of all the variables, the values of all the variables. And then you can troubleshoot and figure out what has gone wrong. In this case, it was an environment variable that wasn't set. And you can use this with Cloud Run or most other products that run code in the Google Cloud Platform. Because you know how it is, right? You have all those test cases, right? And you test, and you have your unit tests and integration tests and all that. But when you put it in production and you productionize your code, you deploy it in production, there are those special errors that only happen in production. And they're so hard to reproduce. But now you can. You can even put conditional breakpoints in here. And production runs just fine. It doesn't actually stop the code from running. So users don't notice any slowdown or breaking. Yeah?
I see that the file tree, there's a cloud repository.
Yeah. Oh, right. Good point. So this is the code is checked into this into Git inside Google hosts Git as well. So inside this project, you can do it with or without using the source control that's built into. You do need to import one library. Yeah. If you import a library at the top of your file, then you're good. All right, great. Almost there. 75% there. This is looking good. Open pet data to insurance companies and calendar syncing apps. Okay, that's the last part. What kind of API might we build, should Ruby build here to open up to the internet, open up the database? Any thoughts? HTTP, very good, very good. And within HTTP, it might be a REST API, yeah, for example. Or if you're old school and you like your IT 90s style, you can use SOAP or, but yeah, REST is a good way of doing it. So external systems like insurance companies and such, they would hit, and I apologize for this font being so small. It's the standard they make us use. I need to make this font bigger. Here in Cloud Run, she builds a REST gateway, and it uses the Cloud Firestore as its backend. Let's look at what it would. So here's actually the whole get thing. So if there's a get, then we look up the pets collection. We look up the document with the ID, this ID that came in. We look that up. We get a document back. Then we can do doc.data. Then we get the data for that document. Then we just set the header and send back the JSON. So that is get. She would write similar things for post. And what are the HTTP verbs again? There's get and post, and what others? Put, patch, very good. Patch is not everybody remember patch, yeah. Very tricky, yes, I agree. What else? Delete, of course, if you want to delete, yeah. Is there another one I missed? Options, that's right. There's options too, yeah. So she would implement them similarly. All right, let's have a look, see if it works. Yay, it worked, and it was pretty quick too. So this, we're asking for pet with ID 100033. I'll just remove a 0 here to get an invalid ID, and then it looks in the database and it does not find it. Okay, good. So this is working. Now, Patrick has some concerns here, like this insurance companies, they're gonna hit us a lot on the first day of every month. Are you sure this serverless thing is going to stand up to the load? There's only one way to find out, load test. So Ruby runs a load test where she sets it up so there's a 1 minute ramp up. Then it goes from 0 to 600 requests per second. It does that for 3 minutes, and then there's a ramp down. And every request, there's no caching or anything going on here. So every request actually runs the code we just saw, which hits the database and then gets the data back and sends it out. So we see 600 database reads per second, 600 invocations of that code. Let's look at the results. So Google took that code she had and created 85 instances, basically installed her code, her container on 85 machines so that it could handle the load. And then it uninstalled it on 80 of those machines. So it was still installed on 5 just in case load would pick up again. 137,000 requests came in during the test. They all were successes. There were no failures. The median response time was 49 milliseconds, and the P99, it was 120 milliseconds. That means that the latency was less than 120 milliseconds for 99% of the 99% of the requests came in under 120 milliseconds. So those are pretty good numbers, but the best numbers here is actually there was no additional work. That code that you just saw, that was the code that was running. There was no additional provisioning or setting up or bulletproofing the system or configuring scale up or scale down. This just happened. And then, of course, because she pays per invocation, there's a cost to this test. So 137,000 reads from the database end up costing 8 cents. So yeah, unless they get more than this, she could run another load test. But this seems to probably hold up to the insurance companies hitting their system. All right, all done. All done. But at this point, Lily comes back to Ruby and says, look, one of my tenets is that the clinic is very environmentally conscious. Now, I have heard customers tell me, right, that these these data centers are huge and they use megawatts and megawatts. And is it really environmentally responsible to move our stuff into a data center that sucks down so much energy? There are a few different ways you can look at this. One way is you can compare with other cloud vendors. Greenpeace, every few years they publish a report, and I'm very proud of working at a company who got an A from Greenpeace. Google continues to set the bar for clean energy advocacy. They said some very nice things about Google in there. And I do believe that Google is the only company, only major cloud vendor that did get an A on this report. You can also look at, there was a report from United States Data Center Energy Usage Report. So this was sponsored by the Department of Energy in the US. And it's interesting, this is how they estimate how much data is used. Like the blue stuff, regardless of how you run your server, it uses the same amount of energy, blue bars, right? But if you run it in a server room, you use an additional 150% for overhead, cooling and transformation, losing transformer losses and so on. Now, it gets a little better if you move to a localized data center, mid-tier data center, high-end data center is a little less. If you move to a hyperscale data center, it's really much smaller. Hyperscale, that is basically your major cloud providers like Google and the others. Now, hyperscale is basically 20% wasted energy. Ruby is actually moving to Google here. So Google, the waste is actually just 11%. And if you run your stuff in here from Denmark, you may choose to run your stuff in the Hamina data center in Finland. It's close by. And there, the number is 9%. The newer data centers are far more efficient. Also, Google buys lots more renewable energy than anybody else. So a lot of this is powered by renewable energy. Great. Lily's happy. Ruby is happy that Lily's happy because that means she'll get paid. Everybody's happy except Patrick, because he has one big question. He wants to remind you all that I've been standing here talking for 40 minutes about cloud computing in veterinary hospitals without mentioning the elephant in the room. Which is best, dogs or cats? And you are all going to vote. So if you would please pull up your phone or your laptop and go to pet-theory.web.app And there will be an app there that Patrick built for you where there's 2 big buttons, cats or dogs. And I'd be very interested to see which is the favorite animal in the crowd here tonight. Also, once you've gone there, at the bottom of that voting page, there is this link, this bit.ly link, Cloud Run Talk. Please go and fill out the survey, and there will be a Flick Smart button that I'm going to raffle off in just a few minutes among the people who filled out that survey. So while you're working on this, we'll do the drawing in a few minutes. Are there any questions?